A very good morning, everyone. Once again, very warm welcome, a heartiest welcome, a heartfelt welcome to one and all, each and everyone present over here to the second day of AgriVision 2026 on the compelling theme of sustainable agriculture, food and nutrition, rural livelihood development. We welcome all our participants, those who have joined us virtually. I think I'm audible to all of you. Am I
Yes,
audible?
a very good morning, madam.
Good morning, a warm welcome. Our first presenter is with us, Divyani Ramola. But before that, let me welcome our chairpersons for the session with a round of applause. It is my honor to introduce Dr. Deepa Samant from ICAR IIHR CHES Bhubaneswar, and we are having the rapporteur for the session, Dr. Tanushri Sahu from ICAR IIHR CHES Bhubaneswar. We welcome both of them. Let us have a round of applause for both of them. And also Dr. Konindya AVB will be joining us in a while. For now, let us start with the presentations. Divyani Ramola, she is joining us from GBPU UT Patnagarh, GBPU AT Patnagarh, and she will be presenting on millets for nutrition and climate action and integrative review of agronomy, processing and nutritional outcomes. Divyani, we welcome you. Please share your slides. Am I audible?
Yes, ma'am, you are audible. I will be sharing in a minute.
Yes, take your time.
So, is the screen visible?
Yes, it's visible. Your first slide is visible.
Okay, so good morning, everyone. My name is Divyani, and today I will be presenting a review on millets for nutrition and climate action. So, India's food system is currently dominated by rice and wheat. While these cereals have supported food security for decades, in recent years they have become increasingly vulnerable to climate stress. In contrast, millets thrive well in rain-fed and marginal environments, require far less water and tolerate heat and poor soils far better than rice or wheat. Beyond climate resilience, millets are also nutritionally superior, particularly rich in iron, zinc, calcium, and dietary fiber. So, this review today focuses on how marginal crops like millets can actually be integrated into real food system, what the existing evidence already tells us, and where the gaps lie from production all the way to consumption. Methodology. This study synthesized peer-reviewed literature from Scopus, Google Scholar, and FAO database. So, starting at the system level, studies showed that when irrigated rice was replaced by millets through system-scale modeling, results whereas blue water use declined by up to 30%, calorie supply was maintained, and protein availability increased by around 8 to 9%. This shift also redistributed production away from groundwater stressed regions such as Punjab and Haryana towards rain-fed and semi-arid districts, which reduced production stress in these regions. And similarly, on intercropping, finger millet with legumes was shown to increase system productivity and land use efficiency. Similar other studies have also shown that millets can be used for long-term sustainability. Now, when we talk about integrating millets into the food system, the evidence shows that three pillars have to move together, namely production, processing, and procurement. Starting at the production level, outcomes are shaped by two factors. First, choosing the right genotype for a given environment, and second is combining these genotypes with targeted nutrient management. Breeding trials have already identified several millet genotypes that have high iron and zinc, like Dhan Shakti, GPU28, and more. Now, pairing these varieties with targeted management like combined soil and foliar application of zinc and iron increases grain zinc by almost 6 to 30% and iron by over 10%. Often, alongside yield gains are also achieved. Similarly, combined soil and foliar application of zinc and iron at 30 and 45 days after sowing increased pearl millet yield from almost 1.48 to 1.90 ton per hectare and iron from 177 ppm to 197 ppm. So here, production side evidence clearly shows that nutrition can be enhanced on farm. And now moving on to the second pillar, that is processing. Raw millets contain phytates which inhibit mineral absorption in the body. Therefore, processing here becomes an essential part. Studies have shown that germination reduces phytates by over 50% and fermentation reduces them by around 70% and also increases iron and zinc availability by up to 1.5 times. By combining germination and fermentation, highest gain is achieved. However, most of these evidence is derived from small and controlled studies. Translation into real food system through scalable processing, supply chains, and consumer-ready products remain limited and require validation. Moving on to the third part, that is procurement. Existing policies and schemes for millet distribution are as NFSM millets and some state millet missions. Also, state level inclusion is through PDS, midday meal, and ICDS. Although these are clearly not enough, as millets, as of now, account for less than 2% of total public grain procurement. Even in 23-24, only about 17% of approved millet targets were actually achieved. Existing policies are not enough as their implementation is uneven, geographically constrained, and institutionally fragile. In conclusion, millets combine climate resilience and high nutritional value, making them uniquely suited for future food system, and evidence already shows that they can reduce water use, maintain productivity, and deliver higher micronutrient density. Farm level gains through improved variety and management and nutritional gains through processing are already proven. What remains missing is large scale real world validation and system level alignment across production, processing, and procurement in order to move millets from marginal crops to core components of resilient and nutrition secure food system. Thank you.
Check. Thank you very much, Divyani. Well presented. A round of applause for her. Over to the chairperson.
Is it on? Devyani, it was a nice presentation, but I have few suggestions for you. As you were presenting now, so you were just reading out. So kindly take some pause while presenting, and you were very confident. That is a good thing. And now we will open the session for the few questions. I request participant, they may ask few questions.
Let us take some questions. Is there anyone from the participants? Can we have some questions? Is there any question for Devyani?
Okay, let me ask one question, Devyani. What are the main challenges faced by the farmers in scaling up the production of the millets?
Okay. Ma'am, so in the farmer level, as of now, the main challenge is mostly for policies and schemes because if when the farmers poses risk as the MSP for millet is not as much as for other cereals like major cereals like rice and wheat. If more policies were to be implemented in farmers while keeping in mind the farmers benefits, they can start growing more millets away from these major cereals. And second off can be validation like these varieties which are and processing methods which are evidence are mostly derived from small scale studies. They are to be validated in the farmer's field to check whether same results are derived or not.
Thank you. We can take some. Dr.
Yes, this
Tanu,
is,
would you like to ask? Okay, there are no
Yes, is
questions.
there any question from any participant?
yes, ma'am. Myself, Mahendra Chaudhary, ICR Kadri, Jodhpur.
Yes,
I'm
sir.
just asking that what is the process product which was used by national level or international level? Millets are a important. Yes, I'm audible, ma'am.
Yes, please ask. Divyani, can you hear?
Yes.
Mahendra sir, please repeat.
Uh,
So please ask.
hello, hello, hello. Audible, ma'am. Hello, madam. You are audible, me?
Check, check. There was some technical error. We welcome you all once again. Let us continue with the questions. Mahendra sir is there, Devyani is there. Mahendra sir, please go ahead with the question. Can you hear me? Am I audible?
Yes, ma'am, you are audible.
Yes,
Yes.
madam. I'm audible.
Sorry for the interruption. There was some technical issue. Let's move
Okay, okay.
ahead with the question. So please ask.
Madam, I'm just asking a question from my side. What is the role of millets in processing industry? How to increase farmer income by this industries?
Divyani, is it audible? Divyani, are you there?
Devyani? Okay.
Divyani, yes, is there.
Hello. Am
You
I
got the
audible?
question? Yes, you are very
Yeah.
much audible.
Sir, can you please repeat the question once again?
So kindly repeat the question.
Hello, madam. How to improve farmers? How to improve your incomes by processing industry? Because of I am just seen this topic, this point in your title. What is the processing?
Okay, sir. So the processing part
Which,
was most.
yes, yes.
So the processing part was for mostly at the level of industrial level, because processing of raw products into final products will be done at industrial level. So the methods, different methods were obtained for that, starting from conventional methods like roasting and boiling that were initially used by industries, but they ultimately reduces mineral absorption in the body due to anti-nutrients. But if we shift to more modern methods like fermentation and germination that are found in new studies, they, through these processing, the final products that is available in the market can increase uh, iron and zinc bioavailability in the in our bodies. So this part is mostly for industrial purpose rather than for farmers.
Please, madam, please tell me about some products like which was available in market.
Like products of kodo and different ragi products. Example,
Madam,
kodo is
this is
one of the most.
this is the
Yes, sir.
varieties of millets. Okay, madam, no
Yeah.
problem.
Thank you very much. That was absolutely interactive, and Divyani was with us from GBPUAT, Govind Ballabh Pant University of Agriculture and Technology, which is also known as Harvard of India, the very first agricultural university of India. We wish you well for your future endeavors, Divyani. Thank you for joining. Moving on, we are having Dr. Nandini Palth with us from PJTAU Hyderabad. Ma'am, are you there?
Yes, madam. Yes, madam. A very good morning to dignitaries.
Yes, she will be presenting on crop water,
Yes,
budgeting, and yes, a spatial estimation for different establishment methods of rice.
Yes, madam.
Ma'am, let's continue with your presentation.
Okay, madam. Madam, is my screen visible?
Yes, yes, ma'am. Go for it.
A very good morning, madam. I have conducted my
Ma'am,
PhD.
sorry for the interruption, ma'am. Can you make it in a landscape mode? Make
Madam,
it landscape.
actually, it's an image preparation, madam. As I got instructions to prepare in this manner, so I will stick on to it, madam. Is it
Okay,
visible?
please go.
Is it
Yes, it
visible,
is
madam?
visible. Go ahead.
Actually, it's a
Yes,
e-poster, so I made in this direction, madam.
Okay, okay, ma'am.
Okay, madam. Actually, what is the basis for this research is Telangana has emerging rice bowl of India, and my study is related to irrigation, where paddy takes much of the water. What we found is we have chosen a canal area in Telangana so that we can, which is a hot, that is Nagarjuna Sagar project, so that it is well related to other projects in Telangana. So what my study is in the rice we have taken up, and we had identified a problem that when we see a canal area, the top reach is benefited with the irrigation facilities provided by the canal, and they are able to take 2 to 3 crops per year. And when we come to the tail end, there is a deficiency or scarcity of water. So I have taken a field study with the rice in the nearest research station, that is KVK Kampasagar, and have conducted field experiment on irrigation. If you see a diagram here, it's a drum culture technique which is used to measure the water level in the field. That is, water balance is conducted to the drum culture technique, and I have measured daily water index, and also AWD pipes, that is alternate wetting and drying pipes, were installed in each and every plot, and daily observations were taken. And these observations, when we combined, and water requirement of the paddy was computed, and all over the canal area have taken the GT points. And remote I have related this study to the remote sensing part, and indicated the nearby canal area, that is Mudimanikam canal of the Nagarjuna Sagar project. The crop water requirement which we have got has been validated with the crop water requirement through the crop pad, and also remote sensing taken data. They are validated, and there was no the approximation, the correction was also correct. And also we have given the area maps. If you see the area map, the top most reach of the canal area was benefited, and much of the rice was taken. When we come to the tail end, cotton was the prevailing rainfed crop. This is because due to this water scarcity, and also much of the water wastage in the top region. So I have taken up a field experiment conducting the irrigation studies in the transplanted rice, wet direct seeded rice, and direct seeded rice with the irrigation treatments, continuous submergence, AWD, and saturation. I have checked among these which is performing the good. Among these, the establishment method, that is wet direct seeded rice, that is sown through drum seeder, has performed very good and also given on par results with the transplanted rice. And if you see the irrigation studies, even though the numerically continuous submergence has benefited, but it has shown on par results with AWDA, that is alternate wetting and drying irrigation, also giving the standard competition to the continuous submergence. So we have concluded that if we go for short duration varieties, where the paddy area, the command area was much of with the long duration varieties, and also they are practicing the conventional rice methods. If we replace these conventional methods with the new direct seeding technologies, that may be direct seeding or wet direct seeding with the through drum seeder, if we go such practices, there will be a reduction of nearly 15 to 20% of water can be saved in the conventional practices. And if we go with the short duration varieties and establishment methods like wet direct seeding methods, so the saved water can be benefited to the tail end rich people, and this can bring additionally, if you see, 2,700 to 3,000, approximately it is 3,000 hectares additional land can bring into the cultivation by saving the water from the tail end region. This is the overall theme of my research, and it has been depicted as the mentioned subheadings has given by the agrivision. And by this I can conclude that the water that is saved from these methods or by taking these irrigation practices can be benefited to the tail end region, and they may also take at least 2 crops of rice in the Kharif seasons. And thank you for giving this opportunity, madam.
Thank you very much, ma'am, for your participation. Very well presented. Over to the chairperson.
Adishri, we can take questions from
Yes,
the participant first,
yes.
then
Yes. Is there anyone with some questions? Can we take some questions? Is there any question, anyone? Let's take some questions from the participants.
okay, if there are no questions from participant side, Dr. Nandini, how much water is required to produce 1 kg of rice?
Actually, madam, as per literature, we can see, and as per also my studies, it is nearly 3,000 to 5,000 liters of water to produce 1 kg of rice.
3,000 to 5,000 liters of water is
Yes,
required.
yes.
So, which method of establishment was found effective or efficient in terms of water productivity
Yes, madam.
in your
Definitely
case?
direct seeded rice, which we have sown through drum seeder, madam. Which we have sown through drum seeders has performed good, madam. Another important point also, madam, if yield or 5 to 10% yield reduction is also convenable for us also, we can take direct seeding with seed drill. Like ID crops, we can sow the rice with using the seed drill, that is direct dry seeding rice is also beneficial, madam. But there is a somewhat yield losses when compared to conventional paddy. But if you see conventional paddy, if we give a target, apart from that also we can get wet direct seeded, that is we have sown with the drum seeder, has performed good, madam.
Thank you, Dr. Nandini. Thank you.
Thank you, madam.
Thank you very much, ma'am, for your valuable participation. Moving on, now we are having another participant from GBP UAT Patnagarh, Batsala Tiwari. Let's welcome Batsala Tiwari, and she will be presenting on impact of heat stress on anti-nutritional compound in garden pea.
Poster number 4.
Hello. Good morning.
Yes. Yes, you are audible. Please go with your slides.
Okay. Good morning, everyone. My name is Vatsala Tiwari, and I'm from Govind Ballabh Pant University of Agriculture and Technology, Pannagar. And today I'm going to present my poster on the topic impact of heat stress on anti-nutritional compounds in garden pea, Python sativa. So, my poster focuses on the impact of heat stress on anti-nutritional compounds in garden pea, which is Pisum sativum L, specifically phytic acid and tannins. So, garden pea is nutritionally rich, but the presence of anti-nutritional factors like phytic acid and tannins, they can reduce the mineral bioavailability and protein utilization. Since rising temperature is a major concern in India and many parts of the world, under climate change, so we evaluated how heat stress alters the accumulation of these compounds basically in the crop. So this experiment was carried out at VRC Vegetable Research Center of Govind Ballabh Pant University of Agriculture and Technology, Pannagar during the Rabi season 2024-25 season. We evaluated 20 garden pea genotypes along with 2 checks using an augmented block design under the normal season and also under heat stress condition. So our results showed significant genotypic variation for both the traits under both the environments. So under heat stress, we got phytic acid content. It showed an overall reduction with a mean decrease of about 2.7% compared to normal condition. And in contrast, tannin showed increased consistently, showing an average increase of about 17.3%. So most genotypes exhibited reduced phytic acid under heat stress with maximum reductions observed in PSM 160, PSM 164, and PSM 197. Tannin content increased in all genotypes with the highest value under heat stress recorded in PSM 198, PSM 201, and PSM 153. So, in conclusion, the heat stress significantly alters anti-nutritional profiles in garden pea, reducing the phytic acid but increasing the tannins amount in the crop. So, these findings are important for selecting the heat-resilient genotypes with improved nutritional quality, and it can support future breeding programs under changing climatic conditions. Thank you, ma'am.
Thank you very much. Yet another insightful presentation. Very innovative poster. Well, is there any question from anyone? Is there any question for Batsala, everybody, anyone? Can we take some question? Okay, let us have the feedback valuable of the chairperson.
Vatsala, it was nice presentation. Congratulations. And I have one question. How does this heat stress affect the protein digestibility and mineral bioavailability? Have you done any study on that aspect? Am I audible to you?
Ma'am, can you please repeat the question?
Okay. How does this heat stress affect the protein digestibility and mineral bioavailability? Have you done this study or not? Only this anti-nutritional compound, phytic
Ma'am,
acid,
Ma'am, I have
tannins.
done Ma'am, I have done just this anti-nutritional aspect, and I've only done the screening part. I've taken genotypes, 20 genotypes, and I've just screened them out. I've sown them in
Okay.
normal season as well as in heat stress, and then I have screened them out on the basis of how they can perform better in heat stress.
Okay. Devjani, please go ahead. Adyashri. I'm so sorry.
Thank you so much. Very innovative poster. Uh, Good luck for the results. Let's wait for that. Now, moving on. There is one participant, Mohendra Chaudhary, if I'm not wrong. Sir, are you participating? Your name is not enrolled. You are there since long. Can I ask you, are you participating today?
Yes, madam.
Are you going to-
Surjit Singh Bharat. Actually,
Okay.
madam, he is not here. He is going to
Okay.
any meeting, so
Poster
therefore I
number
will
3,
present this
EP3.
poster.
Okay. You are going to
If he had.
okay. You are going to present behalf of Surjit Singh Bharat.
Okay, ma'am.
You
Yes,
are going
madam.
to present behalf of Surjit, right?
Yes, madam.
Okay. Let us begin. And we are having Mohendra Chaudhary. He's going to present on innovative technologies for the effective management of wild herbivorous in semi-arid agricultural landscape of Jodhpur, Rajasthan. Please go ahead, sir.
Madam, screen is visible?
Yes, yes, sir.
Okay. Today I am present on my research topic, which was conducted on farmers field, innovative technology for the effective management of wild herbivores in the semi-arid agricultural landscape region of the Jodhpur. Introduction. Growing agriculture has a reduced natural habitat of wild animals. It is a major problem to enter in the farmers field due to habitat loss, which was wild herbivores enter in the crop field and cause the crop damage. So therefore, those animals are protected by Wildlife Act. So therefore, we will not kill in this farmer field. So therefore, I will. Some non-lethal and eco-friendly methods are needed to protect the crop to conserve wildlife. Study area, we was selected the five selected villages which was located in Osia Tehsil, Jodhpur district, Rajasthan. Uh, Crop was selected for the evaluated these strategies: bajra, moong, or guar. The major crop which was sown in this areas is bajra, then moong, then guar. The data selection was the some objective was followed for the experiment to evaluate the ecological best non-lethal management technology for wild herbivores to assess their effectiveness in reduce the crop damage. And then last one is identify the most effective treatment which was reduce the damage in the crops. The data selection method was low quadrant methods. We will select the 10 by 10 meters area. Then how many plants are damaged and how many plants are healthy plants which found. And then sighting of the animals, it is the major agenda for this project. Economics of the different treatments which was collect the from the farmer side. Technology related the some include the control. First one is bioacoustic devices. Second one is e-cannons. Third is all factor reflectors, and the fourth is solar fencing. Fifth is combined of all reflectors and solar fencing. Reduce. We will concluded to the reduce of the damage over control. The combination of the solar fencing and repellents, which was made by our institute, Kerala Agriculture University, which was made by the some repellents, olfactory repellents and solar fencings. The major treatment was found to reduce the control by the damage in agriculture. Then second one is solar fencing. Then third was the olfactory repellents, e-cannon and bioacoustics, fourth and fifth position. Economic assessment by in bajra crops, nilgai damaged by 60 kilogram per hectare, damaged by kilogram per hectare. Yield losses we was found. The economic losses is 1667.6 rupees per hectare. Economic losses was occurred in the moong crops. By economic losses by nilgai is maximum. Then in guar crops, maximum economic losses was found by nilgai, then wild boar. Those are animals is significant damage in the crop, and this is the major problem at the present time. This is the major problems by the in the agricultural crops. And then calculate the study showed the nilgai and wild boar cause the highest crop damage, leading to significant yield and economic losses, especially in moong and bajra. Then, among the mitigation measures, solar fencing is the highly effective, while the combination for factor repellents and 100% protection, we will occur. We will observe integrated of the solar fencing and deterrent was the most effective, reduce the wildlife induced crop damage. Madam, this is a present time wild boar is a major problem in this particular area. Farmer is very so therefore, because of those animals are protected by Wildlife Act, so therefore I will not kill the permission of the uh, by wildlife. Thank you, madam.
Thank you very much, sir, for the interactive and insightful presentation. Moving on, we would take some questions from the participants. Thank you very much for the informative presentation. Let's take some questions now. Is there any question? Anyone? Is there any question for Mahendra sir? Anyone? Okay, if not, let's connect to our chairperson.
Mahendraji, a nice presentation. So I would like to ask one or two questions. So what is the maintenance cost of the this installment and lifespan what you have used in your study? Are there any maintenance cost?
Maintenance cost, madam, it is solar fencing. I think 5,000, 4 to 5,000 for
Per year?
4 acres. 4 acres, 4 acres is
Per
sufficient.
acre. Okay.
Or madam, second one is deterrent. It is a very most effective from the result found by the farmers. Farmers are fully and 100% satisfied by the from the my side. Farmers are said I am totally free from the wild boars problem because of this is a major problems in the particular this areas. So only 400 per kilo cost is repellents only.
Okay.
So
So what was the active ingredient in repellent? You have used some olfactory repellent, na? So,
no, because madam, it is under trial condition. So therefore, I will.
okay, you are not going to reveal it. Okay.
Yes,
Okay.
madam.
What about the
Exactly.
lifespan of the installed this system? Suppose this electric fencing, solar powered fencing. What is the
What is madam?
lifespan? Lifespan of
Life,
that.
yes, madam. Because of a battery lifespan is 2 to 3 years. Because
Okay. So after 3 years, you need to replace the battery.
battery
Okay.
only replace the battery.
Okay. How much does it
बाकी
cost the battery, sir?
overall जो overall infrastructure is same battery because of only battery is replaced after 2 to 3 years.
Thank
So
you.
sir, there. Okay, thank you, madam.
Thank you, Mahesh.
Thank you very much, sir. Now moving on, let's connect to Tulja Sonam. She is from University of Agricultural Sciences, Bangalore. Ma'am, am I audible?
Yes, good morning, everyone. Yeah, I'm gonna
Yes,
share my
please
screen.
continue with your presentation. She is going to present on irrigation water quality index based assessment of marigold industry effluent and its phytotoxic bioassay. Ma'am, go for it.
Can you see my screen, ma'am?
Yes, it's visible.
Yeah. Okay. Good morning, everyone. I am Tulja Sanam. I am from University of Agricultural Sciences, GKVK, Bangalore. Today, I am here to discuss on the topic of. Wait a minute. It's just tracking, ma'am. Give me 1 second.
Yes.
I'm going to deal with the topic of irrigation water quality index based assessment of marigold industry effluent and its phytotoxicity bioassay. And globally, as agriculture is the largest consumer of water, accounting for nearly 70% of the total water withdrawal, as shown in the regional water area distribution, here we can see around 70% is drawn from South Asia for agriculture purposes. At the same time, the climate changes and irregular rainfalls are intensifying water scarcity, affecting farmers and crop productivity. To address these two challenges, water reuse has emerged as a sustainable solution. The reuse of industrial wastewater can be one of the alternative for reusing water and using it as a freshwater to reduce the freshwater demands, lowering environmental pollution and supporting sustainable agriculture. So in the present study, considering all these factors, marigold industry was chosen, where in the industry they were drying the petals and pressing them to obtain pellets, from which carotenoids and xanthophylls were extracted, which were used in the pharmaceutical industry. And during the process of pressing, there was around 4 to 6 lakh liters of effluent was being discharged into the water bodies every year. So we have taken up this study to reuse this wastewater for agriculture purposes, where 4 to 6 liters of untreated marigold flower effluent was being coming out, which was further treated by primary, secondary, tertiary treatments, and this treated effluent was going into the water bodies. So in the present study, we have taken up treated marigold flower effluent and untreated marigold flower effluent to conduct further studies. Coming to the methodology, firstly, we have the effluent was evaluated for their physical, chemical, and biological properties. And these, based on all these parameters, an irrigation water quality index was developed, where in irrigation water quality index is an indicator, composite indicator to evaluate the suitability of water for agricultural irrigation. It integrates multiple water quality parameters into a single numerical. It includes the parameter weights, parameter subsites, and gives a single value based on which we can decide if the water is suitable for irrigation or not. And later a phytotoxicity bioassay was conducted using tomato seeds of variety Arka Samrat and in water agar. Under controlled conditions in the laboratory conditions, this experiment was taken up by adding the effluent at 6 different concentrations to the water agar and sowing the tomato seeds and observing the growth of those seedlings for 14 days, based on which the seedling length, germination indices, and phytotoxicity indices were calculated. And these results were statistically analyzed using Boltzmann fit graph, using QTI plot, and different multivariate statistical analysis were conducted using the JMP software. And coming to the results, the irrigation water quality index was calculated, as I mentioned, and which was proven to be 10.508 for treated marigold effluent and 45 for untreated marigold effluent, both of which fall under the category of suitable for agriculture. So we have conducted the phytotoxicity bioassay in the glass jars with the water agar at different concentrations of effluent along with the control. And this is a Boltzmann fit graph where you can observe that, which was plotted with shoot length and root length against concentration using treated and untreated effluents. Here you can observe that there was a gradual decrease in shoot length and root length after a certain point, certain concentration, which indicates a toxicity. Means as it is an effluent, it has contained some organic and inorganic compounds which can act as a toxicants for the plant growth. And this is evident from this graph. With increase in concentration, there is a decrease in crop growth. To justify these things, we have conducted different multivariate analysis like Pearson correlation coefficient, principal component analysis, and hierarchy clustering analysis. And coming to the Pearson correlation coefficient, from this graph, we can say that blue colors indicate a negative correlation with other parameters like relative shoot growth, relative radical growth, germination index, and seedling vigor index, whereas the red ones indicate a positive correlation with the rest of the parameters, indicating plant growth promotion and tolerance. Here we can see a positive correlation, which is in red. The R values are from 0.88 to 1.00 for the growth parameters, except the phytotoxicity index and relative toxicity percentage. Rest all, it's positively correlated, suggesting germination and early seedling elongations are highly correlated. And then comes the negative correlation, which is shown in blue. These are negative values which indicate phytotoxicity stress increases. As it increases, the growth declines. And coming to the hierarchy clustering, this was mainly done to group them into different clusters based on their concentration and their performance. Here we can see few of the few concentrations are grouped under red, which indicates this cluster is non-toxic. It was promoting growth, but at lower concentrations, not as effective as these two concentrations which are given in the green. These are highly effective and promoting root and shoot growth, even when used with the treated marigold effluent. And this blue cluster indicates that these effluents are highly toxic and are not suitable for crop growth. Coming to the principal component analysis, we can observe that TMFE, the treated and untreated effluent at lower concentrations, are grouped on the positive side of the PC1 and the positive side of the PC1, indicating that they have robust growth and minimal toxicity, whereas the highest concentrations are grouped on the negative side of PC1, indicating that they are strong inhibitory effect. And there is a biplot drawn, which indicates that relative toxicity and phytotoxicity index are on the negative end, whereas the growth promoting like GI, tolerate index, RRG, SVI, and RSG are plotted on the right side, indicating that on the positive side, indicating that they are promoting the growth. Overall, the combined Boltzmann fit graph, PC, and clustering analysis demonstrate that 0.5 mg per mil as an optimal concentration for treated and untreated effluent for promoting tomato seed germination and seedling vigor, while concentrations above 5 mg per mil exhibited pronounced phytotoxicity effects. Thus, the biological response of MFE is dose dependent, shifting from stimulation at low level to inhibition at higher concentrations. Thank you.
Thank you very much, ma'am. Yet another excellent presentation. Now we are open for the questions or queries. Anyone? Participants are requested to raise their questions or any suggestion or any queries. Is there any question? All right, thank you, ma'am. Once again, over to the chairperson.
It was wonderful presentation by Tulija. Tulija, I have one question. What are the potential long-term risks associated with using such type of effluents on soil health in terms of microbial activity? Have you done any such study?
Yeah, I come from microbiology, ma'am, agriculture microbiology. So this is a part of the study where in this study, the main focus was on plant growth promoting microorganisms. We have cultured those microorganisms in relation with these effluents in the laboratories and conducted a pot culture and field culture experiment with the potato as a major thing. So good results were observed, but only under the diluted conditions, ma'am. Long term, as I haven't conducted long term studies, but the preliminary studies went very well. The results were very good in combination with the plant growth promoting microbes.
Are there any risk for heavy metal accumulation in edible crops?
Yeah, actually, we did the heavy metal analysis, ma'am, priorly for conducting the irrigation water quality index. These have very less heavy metals, ma'am, as it was already undergoing the treatment process in the industry itself. Most of them are being excluded, so there was not much risk. Like, I can't say not much risk. I can say it doesn't have any risk as of now because it's an agro industry effluent.
Okay. Thank you. Thank you.
Thank you.
Thank you very much. Moving on, there is a name showing Anindita Karmakar. Ma'am, your name is not enrolled. Please let us know whether you are going to present anything. Anindita Karmakar. If I am audible, can I ask you, are you going to present today? Your name is not enrolled.
I have already presented yesterday. I just joined to listen the presentations.
Okay. Thank you very much, ma'am. Thank you for your presence.
Hello. Of different location, a tropical climate on Alfisol. So here carbon sequestration means long-term capture of the carbon sequestration storage to mitigate the global climate change. So here the consequences of steadily increasing the level of the carbon dioxide. So we have go for the plant carbon sequestration. So we have taken two topic. One is another for mango, jackfruit, guava. So I am presenting the guava one. So we have taken the two location, Dhenkanal and Raigada. So here we have different age group. We have taken 0 to 5 years, 5 to 10 years, and more than 15 years. So we have first we have selected the plants, then all the plant parts like primary branch, secondary branch, tertiary branch, and the trunk part and the roots part. So we have mixed, we have dried and mixed properly. Then we have go for the further analysis. After that, we have taken an analysis of the carbon dioxide in the CHNS analyzer we have used for the carbon. So here you can see that the global climate change is increasing day by day and year after year, and the highest of the carbon dioxide is the 79% the portion. So we have taken the cultivar Allahabad Safeda with 6 meter into 6 meter spacing. So 277 trees per hectare. We have analyzed the 1 hectare area, that what amount of carbon we have sequestered in the guava orchard. So here is the table. So here the selection of the plants, then recording all the morphological data like canopy, all the primary and secondary branches, all of the data. Then after that sample collection we have done. Then collection of the sample after dried, grinding, sieving, and after that I will go for the further analysis. Go for table number 1. Go for table number 1. ऊपर हाँ ऊपर So here we have recorded the number of primary branches and main girth of the primary branches. After that, it have above ground biomass was 97.85 kg in 5 to 10 years, and in Dhenkanal. How did you mark them? Then these are the Dhenkanal data, another one the Raigada location data. So total number of carbon dioxide kg per tree varies from 64 kg per tree to, in more than 15 years, 157.97 kg per tree. Then these are the soil carbon that have included 77 tons per hectare in the Dhenkanal location. In the Raigada location, 81 tons per hectare. Like that, weed biomass varies from 1191 tons per kg per hectare to 486 kg per hectare for more than 15 years plants. Then after that, total carbon sequestration, then tree biomass, only the tree biomass is 77.67 in 5 to 10 years and 77.5% more than 15 years. Then in Raigada, 81.70 tons per hectare and more than 15 years, the 81.57 tons per hectare. So these are table number 3 is the component of the total guava orchard, that in 1 hectare area, how many the carbon is sequestrated. So total number of carbon sequestration in Dhenkanal is 95.42 tons per hectare in 5 to 10 years plant, in more than 120.37 tons per hectare in more than 15 years plant. In Raigada also, average 114.35 tons per hectare is the total carbon sequestration of the orchard. Okay. So understanding the conclusion is mainly approximately 21 to 22% is contributing to the above ground biomass, and guava orchards sequestered 106 tons per carbon per hectare in Dhenkanal and 114.35 tons per carbon per hectare in Raigada. Yes. Thank you so much. नहीं एक वेराइटी इलाहाबाद सफेदा. यस हाँ रायगढ़ एंड ढेंकानाल. यस मैम. वेरी करेगा, इसीलिए हम लोग एक पर्टिकुलर वैरायटी लेके किए थे।
तो उस एरिया में जो प्रोमिनेंट वैरायटी है आपका अलाहाबाद सफेदा,
अलाहाबाद सफेदा और अलग अलग भी था, पर जो ऑर्चर्ड हम लोगों को मिला जिस एरिया में, तो उस एरिया में वो लेके
कितना था
0 to 5 years, 5 to 10 years, 10 years more than
एज वाइज अलग अलग
हाँ एज वाइज अलग। एक्चुअली मेरा जो काम था 3 अलग अलग क्रॉप में था, मैंगो, जैकफ्रूट, गुआवा, तो आई एम प्रेजेंटिंग ओनली द गुआवा। थैंक यू सो मच।
अभी जो एक और आने वाली वो नहीं आएंगे ना?
नहीं मैम, उसका तो सिर्फ पोस्टर प्रेजेंटेशन था, उसका ये पोस्टर नहीं था।
ऑफलाइन
ऑफलाइन
जो भी एक और आएगा यहाँ पे लिख दूँगी, ज़्यादा कुछ होना। और ये सभी सम्मानित आ जाएगा यहाँ पे, सभी सम्मानित अतिथिगण वैज्ञानिक शोधार्थी वैज्ञानिकों सभी सुनने वाले हैं वो भी नहीं पता।
check. All the participants, those who are virtually with us, welcome back. There is one name, Sanvidha RB. If you can hear me, please unmute yourself.
Yes, ma'am, you are audible.
Yes, good afternoon, ma'am. A very warm welcome to AgriVision 2026. Ma'am, your name is not mentioned here, so if you are going to present, then please let us know so that we can continue with your presentation.
Yes, ma'am. Actually, I asked for oral presentation. They said that they would inform the chairperson and they would let me present in this meeting.
Actually, your voice is breaking.
Yes, there is some network issue, I think. Can you please repeat? You are not audible properly. Are you presenting on behalf of someone?
No, ma'am. Actually, I spoke to one of the organizers and they said that they would allow me to present in this meeting and they said they would inform to the chairperson.
Is it poster for presentation?
Are you ready with your presentation for the poster presentation? Are you ready with your poster?
I asked for oral presentation.
Okay, please, ma'am, go ahead with your presentation. Please share your slides.
Okay.
Ma'am, please unmute yourself. Is it audible? We are not yet able to see your screen. Kindly share.
Is my screen visible?
Not yes, it is visible now.
Can I start my presentation now?
Yes. Your voice is breaking up. I think it is some network issue, or please take care. Go ahead, or your slides are visible.
Ma'am, am I audible now?
are audible, but yes, please go for it.
Yes. Good afternoon, everyone. This presentation focuses on a system analysis of climate adaptation and smallholder agriculture, emphasizing how technological innovation, physiological response, economic conditions, and agriculture policy ecosystems are interconnected. So, smallholder farmers contribute to nearly one-third of global food production, and yet they are the most vulnerable to climate variability. So, climate adaptation, therefore, cannot be addressed through isolated interventions. It needs a holistic approach where biological, technological, social, and policy components interact dynamically.
Sanvida ji, you are not audible. If you are using earphones, please remove. Please use your system speaker. Do not use earphones. You are not audible right now.
I am using my system speaker currently. Is it not audible yet?
Yes, yes. Now please continue. Ma'am, please change your slide and continue.
So why a system approach is needed in climate adaptation is that climate change impacts agriculture through multiple and interconnected pathways. And cross responses depends on ecophysiology, technology access, and management. And also technology adoption, on the other hand, is shaped by socioeconomic conditions, and agriculture policies determining the access and scalability of these adaptive measures. So isolated interventions often fail due to missing of linkages and feedback effects. So that is why a system approach is needed to integrate a resilient and sustainable adaptation outcomes. So the objective and steady nature of this framework is that it proposes an integrative system and it focuses on Indian smallholder farming systems, and it is applicable to similar agroecological regions that are present globally. It also supports research, policy, and sustainability planning. So, climate change on the view of ecophysiological factors, it directly affects crops through heat stress, drought, and elevated CO2 levels. So from ecophysiological perspective, increased temperature causes or reduces photosynthetic efficiency, while drought stress causes tomato closure and reduce transpiration, which will ultimately affect yield and the farmer's income. So crops do exhibit some adaptive responses to this, but these responses alone are not sufficient for long-term or prolonged stress. So this highlights the need for external technological need and institutional support. An agricultural technology system, from this perspective, to support crop level adaptation, there are several climate smart technologies like micro irrigation, climate resilient varieties, digital. However, technology effectiveness is also not universal, and the adoption of these agricultural technology depends on the affordability, accessibility, and farmer literacy, and also the institutional support that has been offered to adopt this technology. So technology alone can't stand alone, and it is not a separate solution. And when we see about the socioeconomic dynamics, socioeconomic factors, they determine strongly the farmer's adaptive capacity. These include small and fragmented land holdings, limited access to credit and insurance, labor constraints, market access, and social and gender dimensions. In many smallholder systems, climate vulnerability, it forms a reinforcing cycle where limited resource restrict adaptation and climate shocks results in economic insecurity. When we see on the perspective of agriculture policy and other institutional ecosystems, they act as barriers or enablers to climate adaptations. So all these supportive policies like crop insurance schemes, subsidies for climate smart inputs, water governance, and extension systems, all this policy effectiveness is often constrained because of top-down design and there is weak local implementation. So this indicates the need for more inclusive and context-specific policy frameworks. Also, public-private partnerships also play a very key role in scaling innovations, and policy effectiveness is often constrained due to these factors. So what the integrated system framework suggests is that when climate stress affects crop physiology, which determines the type of technology that is required. And technology adoption is shaped by socioeconomic conditions. While all these policy frameworks, they regulate access and they determine the affordability and scalability of the farmer. So these components interact through feedback loops where successful adoption enhances resilience and which ultimately informs better policy designs. So on conclusion, climate adaptation and smallholder agriculture, it is a very complex and multi-layered system. Technological solutions alone are insufficient if we don't consider crop biology or farmer livelihood, and if we don't enhance policy environment, we cannot improve resilience, productivity, or livelihood security. So sustainable climate adaptation ultimately emerges at the intersection of ecophysiology, technology, economic structures, and governance. This system-based thinking is essential for future agriculture planning. Thank you.
Thank you very much for the wonderful presentation. Now we can take some questions.
Hello, Ms. Samhita. Can you hear me?
Yes, sir.
So, actually, what do you mean by climate change?
So can you repeat again?
What do you mean by climate change? I mean, how can you interpret climate change?
So I interpret climate change like it is a long-term shift in temperature and rainfall patterns and elevated CO2 levels and like extreme weather events. And like smallholder farmers are very affected due to this dependence because they mostly depend on the rainfed systems. So I guess that climate change, when we are discussing climate change on a larger level, we should consider smallholder farmers and how they are affected by it. So that's why I made this system approach.
Well, can you suggest few strategies? How can a smallholder farmer can come out of this problem?
So when we discuss about the solutions, like I said, all the factors, the technology, eco-physiological factors, and on the policy levels, there must be changes made so that smallholder farmers are included in the discussion and they are not affected by this climate change. Some things that I would suggest is that taking feedbacks from the farmers and ensuring what they need and discussing that at a policy level and bringing that into a technology and then taking that technology into extension activities is very needed, because when we speak about technologies, it's always applicable to very large scale farmers. So we also should bring small scale farmers into the talk and discussion.
So, what is your subject? I mean, you belong to which discipline?
Sir, can you repeat the question?
What is your discipline? You belong to which subject?
BSc Honors Agriculture.
BSc Honors.
Yes, sir.
So, can you suggest some agronomical interventions to manage the climate change? So, in agronomy point of view, can you suggest some strategies so that a smallholder farmer can adopt and manage the climate change?
So maybe adopting for climate resilient crop varieties and adopting some conservative agriculture practices like minimum tillage and using the previous crop residue, and maintaining effective nutrient management and also agroforestry systems. So those kind of agronomic measures could be done.
Yeah. Adopting the cropping systems and farming system approaches. Okay. Okay, thank you.
Thank you, sir.
स्क्रीन टॉप हो गया मैं जो पहले था उसी में से फर्स्ट सेकंड थर्ड करते हैं कर दिया था वैसे अभी चल रहा है वहाँ स्क्रीन का बंद कर दिया